There is an algorithm that we can use to find eigenvalues and eigenvectors of a matrix. Let me go over this for now and then we will see why later. The first thing that we wanted to do is that we want to find the determinant of A minus X times the identity matrix. So I'm gonna start off with this matrix A, 3, 8, 0, negative 1, minus X times the identity matrix. So this is going to be 3 minus x times 1, which is going to be just 3 minus x. I'm going to have 8 minus x times 0, which is going to be just 8. I'm going to have 0 minus x times 0, which is going to be 0. And the last one is going to be minus 1 minus x times 1, and that's going to be negative 1 minus x here. Now, I would like to find the determinant of this guy. So the determinant of a minus xi minus xi is gonna be just the determinant of this matrix, and that's gonna be 3 minus x times minus 1 minus x, 3 minus x times minus 1 minus x minus 0 times x here. So I'm gonna just have 3 minus x times negative 1 minus x, and let me leave it like this for now. This polynomial actually has a name. I'm just gonna call it px. This thing is called the characteristic polynomial of the matrix A here. So this is all we have to do for step 1. And for step 2, I would like to solve for when this guy equals to 0. So I let 3 minus x and negative 1 minus x equal to 0. So I have two things and they multiply to 0. So what could happen is, it could be that 3 minus x equal to 0. In that case, I'm gonna have that x equal to 0, or I can have negative 1 minus x equal to 0, and what that would mean is my x would just be negative 1. This is actually the end of step 2. What I have here is that the two values that we see, wait a minute, if 3 minus x is 0, that means x has to equal to 3. Let me actually just go ahead and change that. And what that means is the two values that we are looking at, these guys are the eigenvalues of my matrix A already. This is the eigenvalues. Now, for the third step, I would like to find all the eigenvectors that correspond to each of these eigenvalues. So what I'm going to do is, for step 3, I need to find the eigenvectors that correspond to these two eigenvalues. So I'm going to have that my eigenvalues is 3 and negative 1. Now, if my eigenvalue is 3, I'm going to compute A minus 3 times I. So in this case, that's going to be 3, 8, 0, negative 1, minus 3 times I, which is 1, 0, 0, 1. In this case, I'm gonna get, let's see, 3 minus 3, so that's gonna be 0. 8 minus 0 is gonna be 8. 0 minus 0 is going to be 0, and then negative 1 minus 3, that's going to be negative 4. Now, I need to solve for the homogeneous system. This thing as a matrix on the left-hand side, and then the right-hand side is just going to be 0. So I need to solve for the homogeneous system, where my matrix is just going to be 0, 8, 0, negative 4, and then 0, 0. Now I can perform the row reduce on this one. I divide the first row by 8, I get 0, 1, and then 0. And then I add 4 times this first row to the second row, and I eliminate that. So this is the reduced row echelon form for my matrix, and my solution is that my x can be anything, and then my y has to equal to 0. So what that means is the solution is going to be just x and 0, or I could write this as x times 1 and 0. So what this gives me is, well, that means the solution to the system that I have is just the span of 1, 0. So what that means is the vector 1, 0 that we are looking at here, this is the eigenvector. This is the eigenvector that corresponds to the eigenvalue 3 that we have from earlier. In other words, the eigenvector that I have is going to be just all vectors in the span of 1, 0 that we have here. So now, let's try to find the eigenvector that corresponds to when my eigenvalue is 1. So I'm going to do the same thing here. I'm going to compute A minus 1 times I. once again, that's gonna be a minus the eigenvalue times I, and because eigenvalue is -1, it's gonna be a minus -1 times I, which is gonna be just a plus I. And that's gonna be 3, 8, 0, -1, plus 1, 0, 0, 1, and that will give me, let's see, 4, 8, and then 0, 0. Now, I need to solve the system for 8, 0, 0, and then 0 on the right hand side. So then I can reduce this guy to just 1, 2, and then 0, 0. So the solution for this is that my y is going to be 3, my y is going to be 3, and then my x is just going to be -2y. In other words, the solution for this is going to be -2y, and then y, which is going to be just y times -2 and 1. So once again, I have found my eigenvector. The eigenvector that corresponds to this eigenvalue is just going to be the span of this vector here. So my orange vector here, this is the eigenvector. In other words, all my eigenvectors are generally just the span of -2 and 1 here.